Today we will talk about connecting the lines or edges in an image. So we'll try to write some code which will do that for us. Let's say you have an image. For now we are taking only black and white image where you have some lines and you need to connect them if they are in the same slope and an intercept. So we will try that. This has an applications in image processing and many other things. So we'll start with the code. So to create some examples to work on, I have created a function which creates an example. Now this has two parameters: how many number of lines you want to take and what is the image size. So for now image size I've taken 100 and number of lines is 1. So this function this np.zeros will create a multi-dimensional array which will have the size of image size and will have all zeros. Now we need to create a line. So every line will have an slope and an intercept. So slope is equal to y is equal to mx plus c. So m represents the slope and c represents the intercept. So I'm taking some slope which will be a random number between -2 and 2 and intercept which will be this. Then I will iterate through the image and using the slope and the straight lines equation, we'll just put number of 1 which will represent a white pixel, and 0 will represent a black pixel which will be the default. So let's run it once. So when you run you get an image like this. So this image or a line particularly, as you can see, is very broken, and in some applications you need to join these lines to make it straight. For example, we are trying to do a project called road extraction where we are using CNN to get all the roads in an image, but due to less accuracy of our model, maybe the roads are broken and you want to connect the pathways or roads using some other things than CNN. So this is one of the way. So what I am trying to do is we'll identify the segments. Now what is a segment? A segment is any connection of pixels. For example, as I am showing here in the screen, if some connected pixels having a slope and intercept represent a straight line, then we count them as segments. So for that I have taken a function here. What this function exactly does is gives us the segments. So I've taken a dictionary, then two for loops to iterate through the image, and if an image is 1, then we'll check all its neighboring pixels. So for that I've written this. Then when I'm checking its neighbor, so we'll follow some rules. The rules are, if only one neighbor is 1, then it's part of that segment, and if more than one neighbor is 1, then it's part of the segment with most of the pixels. If no neighbor is 1, that means we are in a pixel which is starting the segment. So this code represents that. So for first, if neighbors 1, that is the segments. If its length is 0, then we are starting out. Therefore I am taking segments dot length and I am just putting it. Then if a 1 is there in the neighbor and it might be in some segment, for that I am just asking for all the segments. Then I am checking which segment it's present, then we will append to it. And if segment id is more than 1, that is the number of segments we already identified are more than 1, and also we have more than ones in our neighbors, then we have to see which segment has more number of pixels. Then after getting these segments can be merged into single segments with the same slope. For example, if a segment is broken in middle and can be considered as one segment if it has the same slope and same intercept, as you can understand by a line. So for that I'm calculating the slope. I have written a function for that, then merging the segment. So in this code what I try to do is I try to iterate through all over the segments. Then if I check If the difference between the two segments is less than some threshold, then we will consider it as a same line. So for that I have written here. So here, if absolute slope of the segment which we are considering and the slope of the segment which is already there in the merged segments is less than slope threshold, then we'll just add the segments. So we can visualize this by this graph. And after merging those segments, now we can fill in the blanks. Basically the segments, different segments merged into a merged segment represents a line, and the pixels in between these segments should be made one to connect the whole line. So for that we'll merge the lines in the segment. For that I've written a function. So in the merge segments, we take the first point and second point and the last point, next point, and we calculate the slope of it, and we check between the ranges if any point is missing, and if that point is missing in the range, we just append it to this array. Now this array represents all the points which needs to be converted from 0 to 1 to connect our line. So after doing that, when we convert our image, so we get the straight line. So for that we are testing the whole pipeline. We create examples, find segments, then merge those segments, then merge the lines. So in this example, as you can see, there are these broken points, the slopes of the segments, then the number of segments we identified was 11, which are totally connected. Then we reduced it to 1. Then final merge segments were this. Then the missing points, for example, if we could see some missing point here, yeah. So for 1 and 59 was 1 pixel which was white, and 361 is 1 pixel which is white. But as you can see, we can take 2,60 which should have been white to represent a whole straight line, so which our algorithm has identified here. Then we just merge the whole line into one. So this algorithm or way of doing was predetermined for Hugh transform. You can see some videos of Hugh transform in a YouTube video, but this is like a brute force or a very basic way to connect the edges in an image.